Kia ora. Let's crack the code of IUPAC nomenclature. So this is for organic molecules and naming organic compounds. So here's organic molecule and its name. How do they relate? The first thing you always look at is for the functional group. And in this case, we've only got one functional group and it's an alcohol, so it would end in ol. The next thing you look for is the longest continuous chain of carbon atoms, and that is your parent chain. And in this case, we've got 4 carbon atoms in a long chain, and that would be bute for 4 carbon atoms. The next thing we look at is, are there only carbon-carbon single bonds, double bonds, or triple bonds? And then if it's only carbon-carbon single bonds, then we say butane. If there were double bonds, then we'd say butene, and if there were triple bonds, we'd say butyne. Then we look to see where that functional group is on that parent chain. So the OH is on the first carbon, which is listed here just before the ol and after the butane, after the parent chain part. Then we look for any side chains. And so you run your finger along the parent chain, and if you have to backtrack or jump to get to another carbon, it means it's a side chain, and that's shown by the aisle. This means it's a side chain. Then you look for the number of carbon atoms in that side chain. Here there's only one, so we call it meth or methyl. And then finally, where on that parent chain the side chain comes, and it's on the third carbon, and that's where we get the 3. So ol is the functional group, 1 is where that functional group is, N means there's only carbon-carbon single bonds, bute means there are 4 carbons in the parent chain, yl means I have a side chain with meth 1 carbon in that side chain, which is on the third carbon of the parent chain. So let's look at some more detail. You notice I used meth and bute. These are new way of numbering carbon atoms. So learn this new way of counting: meth, eth, prop, bute, pent, hex, hept, oct, etc. The first 4 are a little bit tricky to remember because it doesn't seem to follow a pattern. So make up a mnemonic like meet Ethan, professional butler, or Meta eats peanut butter, something like that. Pent, hex, hept, oct are easier to remember because of pentagon, hexagon, heptagon, octagon, which are more familiar. Then another way of counting is the number of side chains. So if I have, for instance, 2 methyl groups, I'd say dimethyl. If I had 3 chlorine atoms as a side chain in different places of the molecule, I'd say trichloro. Mono is not really used, only in certain circumstances. So let's look at the rules. So the first thing is learn those prefixes. You can't name organic molecules if you don't know the meth, eth, prop, etc. Then when you get given the molecule, you look for the functional group, and then you find the longest chain that contains that functional group. And then you look for any side branches, and you rank that parent chain where the number is the lowest possible one for that functional group. If there's more than one functional group, then you have to do priority ranking, and that will be done in a different video. And now you put it all together by using commas between numbers, hyphens between letters and numbers, and no spaces between the letters. And then you just check again. There are exceptions with the acid derivatives and acids, but if it doesn't belong to that, you don't put any spaces. So it's all one word. 4-methyl, because that is a letter and a number separated. Methylhexane, all one word. And here we have a letter, number, letter, so we use the hyphens again. Here's another example: parent chain, functional group, parent chain, side chain. So this would be more 4-methylhexane, 1-amine, because it's a different functional group. Here in this example, I don't have a functional group, so now the lowest possible side chain gets given the lowest possible number. So there's my side chain, there's my parent chain. Now I could number it either from right to left or left to right. If I number it from right to left in the green, then my side chain's on the 5th carbon, but if I number from left to right, it's on the 3rd carbon. And 3 is lower, so it gets given that name. So let's explore what we mean by parent chain. If I look at this rather complicated molecule, which you are highly unlikely to get in the exam, but I could try and count along the straight line and it only have 7 carbons. Or I could try and look over there, I have 6 carbons. Or I could try along this route and then I have 8 carbons. And that will be my longest chain because I can't make any series of carbon atoms longer than 8 for this molecule. In this case, I don't have a functional group, but otherwise you would have to make sure it contains a functional group. So here are some more rules. The functional group must have the lowest possible number, which we've said. We've also stated that the alkane, if there are no functional group, the first side chain must have the lowest possible number. And here we're saying all side chains must be numbered. And we'll see this in this complicated example. And the first side chain must be the lowest possible number. So here I have my parent chain with these side chains. I have 3 methyl groups and I have 1 ethyl group. So if I number from left to right, my first side chain is on my second carbon. If I number from right to left, my first side chains are on the third carbon. So I start naming from the left, or counting from the left, because 2 is lower than 3. So I've got a methyl on the second and 2 on the 6th carbon, and I've got an ethyl on the 4th carbon. So I've got 4 ethyl 2, 6, 6 trimethyl octane. The tri, because I've got 3 methyls. I've only got 1 ethyl, so it doesn't come there. Notice the ethyl is before the methyl because E comes before M in the alphabet. And notice the commas between the 2, 6, and 6. Notice I have got 6 for this methyl and 6 for that methyl. Every side chain must have a number. So looking at these rules, further rules, so every side chain must have a number. The side chains are written in alphabetical order. And again, we've got a hyphen between letters and numbers, a comma between numbers, and there is no space between the letters. This trimethyl octane is all one word, apart from the acid exceptions. So I hope you can now crack the code of organic nomenclature. Kia ora.